Alright, Panther, this lesson will be on 8.3, day 1, using special factors to solve equation. Content standard. Factor a quadratic expression to reveal the zeros of the function it defines. Language objective. I will be able to explain to a partner what a perfect square trinomial is and how you can recognize one. Okay. Factor of the form ax squared, a squared x squared plus 2abx plus b squared and a squared x squared minus 2abx plus b squared. Recall that a perfect square trinomial can be represented algebraically in either of the form a squared plus 2ab plus b squared or the form a squared minus 2ab plus b squared. Okay, so these are the two examples of our perfect square trinomial. Okay, so we need you guys to memorize these two. Right, so there's one more coming, but let's work with these two first. Okay. Right, so example 1, factor perfect square trinomial. Right, so if you look at 4, 24, and 36, they have a common factor of a 4. So we can factor out a 4. And x cubed, x squared, and x, they have a common factor on x, so we can factor that x. So this leaves us an x squared minus 6x plus 9. And then rewrite the expression in the parentheses. So this is the same as x squared minus 2 times 3x. 9 is a 3 squared. So then this becomes one of our perfect square trinomial. So this becomes x minus 3 times x minus 3. So then the answer will be 4x and x minus 3 quantity squared. Okay, for now we're not solving for x yet. They just want us to factor. Right, for part B, well, if you look at 64, it's an 8 squared. So we can write this as x squared plus 2 times ax plus 8 squared. So this becomes our perfect square trinomial. So become x plus 8 times x plus 8. So this is the same as x plus 8 quantity squared. Right, number 4. Now it's your turn. So try to factor these two out, and I'll give you a minute to work this out before I give you the answers. Okay, one thing that I need you to pay attention is that 1 can be overwritten as 1 squared. Right? So 1 squared is the same as 1 times 1, so the answer is 1. Okay, so always pay attention to this constant term, 1. Right. Okay, next line, number 4. This is the other perfect square. Recall that a difference of square can be written algebraically as a squared minus b squared and factor as the quantity of a plus b times the quantity of A minus B. Okay, so for example, if I were to give you x squared minus 25, right? So rewrite 25 as a negative 5 squared. So this is the difference of squares. So we can be written as x minus 5 and x plus 5. Or you can have written in x plus 5 times x minus 5. Okay, so you give us the same answers. Okay, let's go on to some example. Factor each difference of square. So rewrite 49 as a negative 7 squared. So this becomes x minus 7 times x plus a 7. Okay, as before, we're not solving for x yet, we just factors. Right? So for part B, similar to A, for 49, we can write it as a 7 q squared. So this is a quantity squared. Minus 4 is 2 squared. So this is 2p quantity squared. So a squared minus a squared becomes 7q minus 2p times 7q plus 2p. Right, number 7. Okay, so they said that reflection discussion. James was factoring a difference of square but did not finish his work. What step is he missing? So I'm going to have you guys try on number 5 first before I give you the answers. Okay, so one thing that I need you guys to pay attention to is this part here. This is not a difference of a perfect square. Okay, so a lot of students make that mistake. Be careful with that. Right, so for number 6, factor each of difference of squares. So can we get try on number 6 and numbers 7? Okay, and then this 3 is not a perfect square, so we cannot factor that out. So then this is our final answer for number 7. Okay, so slide number 8. So have you guys try these out, and I'll give you the answer in a minute. Okay, so for number 2, if you look at 32, 80, and 50, they have a common factor over 2, so we can factor over 2. So then this gives us 16y squared plus 40xy plus 25y squared. So then 16 is the same as 4y squared. This is 2 times 4 times 5xy. and 25 is 5 squared. Right? So this gives us 2, 4y. Oops, my mistake. Let me change that into an x. Sorry about that. And this is plus 5y times 4x plus 5y. So it becomes 2, 4x plus 5y quantity squared. Right? Okay, let's go on to number 9. Okay, the same thing, try these two out, and I'll give you the answer in a minute. Okay, so for these two, if you look at 75 and 48, we can factor out with 3. And then x cubed and x, we can factor out x. So this gives us 25x squared minus 16. And 16 is a perfect square, 25 is a perfect square, so we can write this as x. 5x minus 4 times 5x plus 4. Okay? Let's go on to number 10. So now we need to solve this. Right? So solve each equation with special factors. And then remember that we have learned that then the exponent is a 2, so we need to have 2 answers. Right? So when I check your assignment, can many of you just give me 1 answer? We need 2. Right? So this gives us 50x squared minus 72 equal to 0. Since 50 and 72 both are even numbers, so we can factor out with 2. So this gives us 25x squared minus 36 equal to 0. Since 25 is a perfect square, 36 is also a perfect square, so this gives us 5x minus 6 times 5x plus 6 equal to 0, which means that 5x minus 6 equal to 0, or 5x plus 6 equal to 0. So the answer will be x equal to 6 over 5, or x equal to negative 6 over 5. Okay, so we need 2 answers. Right? So for number 6, there's a 3 here, so then that means that we need 3 answers. Right, so let's move everything to one side of the equation first. So we have 18x cubed plus 48x squared plus 32x equal to 0. Right, then they're all even numbers, we can factor out a 2. And then they all have an x, so we can factor out an x. This gives us a 9x squared plus 24x plus 16 equal to 0. And 9 is a perfect square, 16 is also a perfect square, so it gives us 2x. This is 3x plus 4 times 3x plus 4 equal to 0. Remember, say that we need 3 answers, right? So we say that either this x equal to 0, or 3x plus 4 equal to 0, and 3x plus 4 equal to 0. So that means x equal to negative 4 over 3, and x equal to negative 4 over 3. Notice how we have two of the same answers, right? Okay, so then we call this our double roots. Right, so we have one answer, 2 answers, and 3 answers, but 2 of those answers are the same. So that's the end of our day one notes. Right, so your assignment is on book set 8.3 day 1, number 1 through 15 arts. And you also have your HRW. You will set 1 through 10, just do as much as you can. Right, and we need to get a copy down 8.3 day 2 notes. Right, okay, so that's the end of our lesson.